Welcome to another video. We want to solve for x in this, but one thing about math problem is we can use different methods to solve and we'll get the same answer. But today I'm going to use a very short one which will be efficient. So if I let this, if y equals to the cube root of x minus 2, just to make the thing easy. So by taking the cube of both sides, we have y cube equals to x minus 2. All right. And another thing I'm going to do here is if I start this, but if y raised to power 3 equals to x minus 1, so that is still negative 2, and I transfer negative 1 here, so we have y cube plus 1 equals to x minus 1. So what I did is I make sure that x minus 1 it also has an equivalent value. And from this above, I'm going to replace x minus 1 with y k plus 1 and other one with y. That is, if you have the cube root of, so instead of x minus 1, so we replace it with y cube plus 1. Then plus, all right, so plus y equals to 1. And by transferring y to other side, we have cube root of y cube plus 1 equals to 1 minus y. Then, by taking the cube of both sides for the second time, we are going to have y cube plus 1 equals to 1 minus y all raised to power of 3. And we are going to expand this the right hand side values, but we are going to use the Pascal coefficient knowledge to deal with this. And if you have 1, we have 1 1, and the next one is the question of 1 2 1, which when the power is 2, and why the next one is 1 3 3 1 when the power is 3. So since the power for this one is 3, so I'm going to stop here, and I will apply this after I expand it. Then by expanding this, we are going to have, so here becomes y raised to power 3 plus 1 equals to, let's start expanding this. So we have 1 raised to power 3 negative 1 raised to power of 2. Then we have negative y, so and I change this one to plus, so just to make it easy. Then we have plus 1 raised to power 1, that is still 1. Then we have negative y raised to power of 2. Y for the last one, so we are going to get negative y raised to power 3. So then y raised to power of 3 plus 1 equals to 1 is 1, and why this one is negative y, followed by plus y square, and followed by negative y raised to power of 3. So let's start introducing their coefficients from the Pascal. Since we have 4 times and all those coefficients are also 4 times, we are going to put it there as 1 negative 3y plus 3y square, and for the last one we have negative y raised to power of 3. So if this one cancel 1, we are going to have and I transfer this y raised to power 3 to this side, we are having y raised to power of we're going to have y raised to power of 3 plus y raised to power of 3, because it is negative it becomes positive here, and here we have negative 3y plus 3y square. This 2 is 2y raised to power 3. We transfer all this one, and this becomes negative 3y raised to power 2 plus 3y, and everything equals to 0. By factorizing y, since it is common, we have y bracket 2y raised to power of 2 minus 3y plus 3 equal to 0. It is clear that if y equals to 0, the other one will be also equals to 0. And we have y equals to 0 or 2y raised to the power of 2 minus 3y plus 3 equal to 0. But this is not the final answer since we left this thing above as y equals to the cube root of x minus 2. So we are trying to replace it here to obtain the value of x, not y. Hereby we have y equals to cube root of x minus 2. But if y equals to 0, we are going to have 0 equals to, and we take the cube of both sides. So here becomes x minus 2. Then the real value of x here equals to 2 as one of the solution to the problem above. And let's deal with the second one to obtain the other solutions. And here I'm going to use the completing the square method as always, as I used to do. We have y square minus 3 divided by 2y plus 3 divided by 2 equal to 0. So the middle term here, what we are going to do here is we make sure we divide it by 2 and we raise everything to the power, then we add and subtract from both sides. By doing that, we have y raised to the power of 2 minus 3 divided by 2y, then plus 3 divided by 4, okay, and then we square it. Negative 3 divided by 4, we're also going to square this, plus 3 divided by 4. You know, if you subtract these two as well, we're still going to get 0 and back to the normal equation. And by combining the first, second, third together, we have y minus 3 divided by 4 all raised to the power of 2. Then everything equals to here becomes 9 divided by 16 when you expand it and take it to the right, and we have negative 3 over 2. So for this um, 9 minus, so 2 is 16, that's 8, and 8 multiplied by 3, that is 24. By taking the square root of both sides and transfer this 3 over 4 to the other side, we have 3 over 4 plus or minus the root of, so here becomes negative 15, negative 15, and all divided by so the square root of 16 is also 4, which is perfect square. Then we can finalize this y as 3 plus or minus the root of 15i, because the root of minus 15 is a complex root, and it becomes root of 15i all divided by 4. So if this is not the final solution, as we did from the first solution to the problem above, we're still going to repeat the same thing as, so we know y already, and we are going to replace it here as 3 plus or minus root of 15i all divided by 4 equal to the cube root of x minus 2. And by taking the cube of both sides, we still get x minus 2 equals to 3 plus or minus root of 15i divided by 4, and everything is to the power of 3. By making x only the subject, we have 2 plus 3 plus or minus the root of 15i divided by 4 all raised to the power of 3. Though this might not be the satisfied solution for that one, and I'm going to check for x equals to 2 to verify if this is correct or not. So by plugging the value of this, we have cube root of 2 minus 1 plus, so for this one we have cube root of 2 minus 2. So 2 minus 1 is 1. We have cube root of 1 plus cube root of this is 0. So the answer is 1 plus 0, which is equals to 1. So which means x equals to 2 satisfy this. Thanks for watching. Don't forget the steps I use. Subscribe to this channel and never stop learning.